Hi, I am Prabu. I am doing B.Tech Mechanical Engineering in Weldtech Akkaravar and SR Technical University, Avadi, Chennai, Tamil Nadu. And my guide name is Mr.N.Dilip Raja. He is the Assistant Professor of Mechanical Department in Weldtech University. Here I am going to give my presentation of my final year project presentation, and my title name is Design, Fabrication and Evaluation of Miniature Solar Desalination Unit. Here I am going to give the PPT presentation of my project. First, design, fabrication and evaluation of miniature solar desalination unit. Actually, why I have selected this topic? Today we are getting more problems due to two departments. First one is electricity production and next one is pure water production. This is the main shortage of the world. Okay. So we are getting more problem by these things. First, see in desalting technologies. What is desalting? First I would like to tell what is desalting technology. Desalting is a method to treat the water that removes the salt water from the salt from the water. It also called desalination and desalination, but it means the same thing. Desalting can be done in a number of ways, but in the result is always same. Fresh water is produced from the pure water or brackish water is produced from the sea water or brackish water. Desalting technology can be used for a number of applications, but the purpose of this potable water from the saline water is for domestic purpose and municipal purpose. Throughout the world, people have continuously tried to treat the salt water so that it could be used for drinking water and agriculture. Of all global water, of all the globe's water, 94% is salt water from the oceans and 6% is fresh. Of the latter, about 27% is in glaciers and 72% is in underground. Okay, then while the water is important for transportation and fisheries, it is too salty to sustain human life or farming. Desalting technologies have increased the range of water resources available for use by community. Next, here in the desalting process, the water cycle is very essential. I would like to say some words on water cycle. Water cycle. Desalting is a natural, continuous process and as an essential for water cycle. Rain falls to the ground. Once it falls on the ground, it flows to the sea. The people use the water for various purposes as it makes this journey. As it moves over the world throughout the earth, the water dissolves with minerals and other materials, so it became increasingly salty. While in the transit and upon arrival in the world's ocean, the other natural low points like Dead Sea or Great Salt Lake, a part of water is evaporated by the sun's energy. This evaporated water leaves the salt behind, and the resulting water vapor forms clouds that produce rains, continuing the cycle. Next, see here, our main objective is design a small solar steel desalination of seawater. Our main concept is to design a small unit because it should be feasible for all people. Low class people, middle class people can buy it and install it on their homes, and they can produce the water by their own itself. Next one, fabricate a solar steel to evaporate. Next one, fabricate the solar steel to evaporate and condensate water from the seawater. That means our project main aim is to evaporate the water, and we can evaporate the salt water, and we can produce the pure water by the condensation process. So our main aim is to improve the rate of condensation and evaporation so that we can produce more amount of pure water. Next, study the performance of the solar steel with a base model in order to correlate the efficiency of the designed steel. Our main aim is to design two setups. First one is previous setup. It has been already introduced by the people and have been installed, have been used in the regular use. So we have designed the previous setup. Next, we are designing our new setup. Finally, we are comparing the result which is the best, and showing the result. We are giving more amount of result. We are producing more amount of pure water. This is our aim. Next, what carried so far. Here first we have First we have designed the setup by using the CATIA software and some fabrication work. Next we have started the fabrication work, and initially we have completed some amount of fabrication work. We have started to take down the readings. That time we have noticed many drawbacks like condensation, less amount of condensation, air gaps, air leakages, and salt formation on the tray. Many things we have noted, so we are not getting good result. So we have fabricated the setup again by again, and we have improved the result gradually. Next, fabrication process completed. After that we have started to take down the readings. Take down the readings, the variable temperature and variable temperature inside the setup, variable temperature and variable temperature outside the setup, and variable temperature, variable temperature in the output area. We have noted many readings, and we have did the calculation by using the Molière chart. Next, design of the solar steels. First we have completed the design part by using CATIA software. That's just before I said. The solar steel does not require any moving parts. Our design does not require any moving parts such as fans, some moving materials. It does not require anything. And we have designed the setup based on the literature survey. That means previous setup based on the same design. Just we have designed, but something different we have included. The parts of the solar steel. Our solar design. Our project, our design, our setup consists many parts. First stand, next base plate. First stand, next base plate. Third one side cover. Fourth one collecting tray. Fifth one glass cover. Next some pumping works and hemming works, miscellaneous items. Next, this is a base stand which is made by mild steel tubes, square tubes, and the square area is 30 mm into 30 mm. Base area is 1 mm into 1 mm. Base area is 1 mm into 1 mm. Height of the leg is 700 mm. Extension, here we have did some extension work in the edges. Here we didn't show it, but we have did some extension work in the edges. That is 0.2 mm. Next, design of the base plate, which is made by stainless steel, and the edges are hemmed because of to prevent the water leakages, and the base area is 1 meter into 1 meter square meter. Welding at the end, the edges are welded, and the height of the base plate is 50 mm. The measurement is 18 gauge. Next, design of the side cover, which is made by wood, and the maximum height is 500 mm, which is used to support the glass cover. Here we are going to fix the glass cover behind provided. Next, plywood, which is made by plywood. Inner we have given the aluminum foil coating, and the inclination angle is 30 degree, and the thickness of the plywood is 12 mm. Next, this is the collecting tray. Here this is used to collect the condensed water, that means pure water, and which is made by stainless steel. We can use any steel for it, no problem. Next, design of the glass cover. The area of the glass cover is 1 meter into 1.2 meter. Thickness is 6 mm. This is a plain glass. This is our main setup. The solar radiation passes through the glass cover. This is the blaze plate. Here we have filled the salt water. The radiation passes through the glass cover, going to hit the water. So the water becomes heat. So it starts the evaporation. And here also inside the side cover we have given some aluminum. We have stick some aluminum foil for reflectivity. So the solar radiation hits the inner surface of the side cover. Suddenly it reflects. That time the reflected radiation try to escape outside, so it cannot escape because we have sealed the setup thoroughly. So it travels inside the setup. That time the water absorbs the heat energy, so it improves the temperature frequently, so that we can improve the rate of evaporation. The evaporated water vapor floats on top, but it cannot escape outside. We have sealed everything in, so it going to hit the glass cover. Here the temperature is very low, so the evaporated water vapors becomes pure water. Here the condensation will be happen, so the pure water falls down to the collecting tray. Here we are going to collect the pure water, and by through this pipe we can store it storage tank. Here we have attached some storage tank. In this way we are going to supply some pure water, pure air, and this way we are going to fill the salty water. This is our setup, picture of our setup. Two setup we have designed, and finally collecting the pure water and correlate with each others. Thank you.